This tutorial will go over how to fabricate 2-layer KiCad PCB designs using a ComMarker laser engraver. Here we have KiCad open with our PCB design. You're going to want to go to File, Fabrication Outputs, Gerbers, and then select the necessary layers. Here's a reference table with what layers you're going to want to have based on whether you're going to do a one-sided or two-sided PCB. Since I'm making a two-sided PCB, I'm going to want 7 total layers, including front copper, front mask, front silkscreen, and bottom silkscreen, and edge cuts. Click Generate Drill Files, and then Plot. And if you get this warning, just press Refill. And on output messages here, it'll tell you where the files have been saved to. We are now done with KiCad, and we're ready to open up FlatCam. So FlatCam allows you to transform your layers from KiCad into DXFs and SVGs that EasyCAD can read. So once your FlatCam is ready to go, you're going to want to go to File, Open, Open Gerber. Then go to the correct folder on your computer and open up the 7 or 4 layers that you exported from KiCad. Once they open up, it'll look like this, and they'll all populate on the left over here. You can then double-click on the front copper layer and select Isolation Routing. Here you're going to want to change the overlap from 10 to 70% and change the passes from 1 to 15 passes. You then hit Generate Geometry and you will see these red lines. These represent the copper that's going to be removed. And as you can see, there is now a front copper in the Geometry tab. You're going to want to repeat this for the bottom copper layer. We now need to import all of the whole files. So you're going to want to go to File, Open Exelon, and then select the PTH file. You then want to export this by going to File, Export SVG, and then save it to the correct folder. These 2 geometries are our trace layers or our copper layers, and they are going to be exported as DXFs. So you can right-click them and then export them, and then save them to the correct file. The rest of these layers are going to be exported as SVGs, so just do the same thing you did for the Exelon file. One exception to this is the edge cuts file. If you want to laser cut the outline of the PCB, you're going to want to do isolation routing on this layer. So you're going to want to do 15 passes at 80% overlap. You can then save this file as a DXF file. This step is completely optional because even in this tutorial, I will be cutting out the edges mechanically with a shearer. And with that, you're ready to open up EasyCAD. In order to successfully open up EasyCAD, you're going to need to turn on the ComMarker. This means that you need to put on your gloves, your mask, and if you want, your safety goggles. The green shield on the ComMarker keeps your eyes safe, but if you want the extra precaution, you can always use the safety goggles. You can now use the knob to turn the fume extractor on all the way, remove the lens cover, and you can turn on the ComMarker by pressing the power button. Plug in the ComMarker and open up EasyCAD. And I know it looks like you're selling your firstborn child, but it's probably fine, just press agree. Click on File, Import Vector Files, and select all of the files that you exported out of FlatCam. If you're making a 2-sided PCB, you're going to have 2 DXF files for the copper traces and 5 SVG files. You will have a total of 7 files. If you're making a 1-sided PCB, you're going to have 1 DXF file for the front copper traces and 3 SVG files. That is a total of 4 files. This is just a sped up video of me importing all of the files I need. When you import your PTH SVG file, which is the file for the through holes and vias, it might be off-centered. So what you're going to do is zoom in a lot and drag the whole layer so that the holes are concentric to the traces. So now that all the layers are aligned relative to each other, you're going to want to make sure that the entire design is centered. So you want to highlight the whole thing, go to the left over here, and make sure that you are centered at the center circle and that your X and Y are both 0. Now you want to enter the settings for each individual pen. Here's a table for your reference. The easiest way to switch between pens is to use this menu right here. Pen number 2, the red one, is specific to cutting holes. Note that the settings you put for pen 2 right now will change later. But for now, just put these. The rest of this clip is just a sped up video of me filling in the rest of the pen settings. Once your pen settings are filled in, you can assign the different pens to their respective layers. You do this by selecting the layer, right-clicking on a pen, and clicking Apply to Pick Object. The layer will then take on the color of the pen that you assign it to. Since pen 0 is black, you won't really see a change, but for example, pen 1, which is blue, you did see the traces change color. The holes will use pen number 2, which is red, and the pads will use pen number 3, which is lime green. And for the pads, you're also going to want to do a hatch, Basically, you click this H over here, you switch to pen number 3, and you want to change the type to concentric circles. You press OK, and it applies. You then apply pen number 4, which is pink, to the bottom pads. It's the same process. You're going to want to change the pen on the hatch to pen number 4, change the type to concentric, press OK, and make sure that it's centered correctly in the right spot. Now we can move on to the silk screen on the front. So you're going to want to apply pen number 5, change the hatch to pen number 5, and then change the type to the snake, and then press OK. The bottom silk screen will use pen number 6, which is orange. So you just select the layer, change it to pen number 6, and then obviously change the hatch to snake and pen number 6. You press OK, and then you are done with silk screen. Now you want to make sure that everything that's going to be on the bottom side of the PCB is flipped horizontally. So in this case, the pads and the silk screen are already mirrored, but the blue traces still need to be mirrored. To mirror it, you select the layer and then hit this button. Since the y coordinate of this layer is already 0, we don't have to flip the sign, but if it was a non-zero number, we would have to either change it from positive to negative or from negative to positive. And like I said earlier, all of the other bottom layers seem to already be mirrored correctly. For example, these pink pads are centered onto the traces, and the silk screen is also centered. But if you want extra confirmation, you can always check KiCad. At this point, the EasyCAD file is ready, so you can go ahead and save it. Now you're going to want to prepare your double-sided FR1. Measure it and cut it using the shear at Lab 64. Make sure you're wearing your safety goggles. You want to cut out a piece that is slightly larger than your final PCB size. Once you have your piece cut, you can align it all the way to the right on the clamp. Then check to make sure your laser is focused. If it's not focused, you use these up and down arrows to focus it. You know it's not focused if the 3 dots are not converged. So you use the up and down arrows to focus the laser until the 3 dots converge into 1 dot, just like this. We are now going to start engraving by drilling the holes. So select the holes layer, make sure you have the correct settings, and press red. This will shine a laser onto where the holes will be engraved. Once you've confirmed that they're in the correct spot, you can go ahead and press mark. This will start to engrave it. You want to do this twice, and it will end up looking like this. Then change the settings of pen number 2 to the second round settings, and then press mark. The reason we do this is to only remove the top copper layer. This will make sure that we have a good surface finish and that we don't have any burn marks. After the second round, it'll look something like this. Then change the settings to the third round setting and hit mark for a total of 3 times. This will burn a hole halfway through the FR1. Now you can flip the FR1 over horizontally and place it all the way to the right. You then want to flip this layer on EasyCAD, so you select the layer and flip it horizontally. Since the y coordinate of this one is a non-zero number, you're going to want to change the sign, and this will align it correctly to the bottom traces. If you want easier access to this layer, you might consider moving up some of the pad layers, and then you can always move them down later. So yeah, select the layer with the holes on it, and then change the settings back to round 1, and hit mark for a total of 2 times. Then switch the settings to round 2, and mark it twice, and then switch the settings to round 3. You will mark this 3 times. You can now poke the holes with a needle to make sure that they have in fact gone through. If they haven't, just do a few more rounds. Once they've gone through, you can go ahead and do the traces on the bottom layer. So select the blue layer and hit red to make sure that it's centered correctly. Once you see that it's centered, you can go ahead and mark it. You will do this a total of 8 times. After 8 rounds, you should be able to see that the traces are a color gray. This means that the copper has been removed. Once that's done, you can remove it and flip it over so that you can do the top traces. So on EasyCAD, select the top traces, which are black, and you might want to press red to make sure that it's centered properly. Once you've confirmed, you can go ahead and hit mark and do it a total of 8 times. In order to double check that it's properly conductive, you can probe at it with a multimeter. Once you've made sure that it's properly conductive, you can go ahead and apply a silkscreen. And you're going to do this by placing silkscreen fabric into an embroidery hoop. Make sure that you pull it taut and tighten it properly. Then lay out a napkin, put your PCB on it, and place the embroidery hoop on top. You want to apply a line of solder mask and drag it out uniformly across the PCB. You can then place the PCB into the UV light curer. This process takes about 5 to 30 minutes to cure, so just check on it periodically. Obviously, you want to do both sides. Once it's cured, place it back into the laser engraver. Go to EasyCAD, select the silkscreen layer, press red to make sure that it's centered properly, and then you can go ahead and press mark. You want to remove just enough green so that the copper is visible. You can then dab a few dots of white solder mask onto the PCB. Literally just wipe it around with a napkin so that the white hits all of the crevices that you engraved. You can then cure it in the UV light curer for a bit. Repeat these steps for the silkscreen on the bottom layer. Now it's time for the pads, so you can select the green layer, which is on the front side, hit red if you want to center it, and mark. You will likely have to do 4 to 8 repeats of this depending on how thick you applied the solder mask. Just repeat until the copper is fully exposed on the pads. Obviously, you're going to want to do this for the bottom layer too. And with that, we're officially done laser engraving things. It's now time to add the vias. You start off by tinning this very thin 36 gauge wire. This is a practice via on a dummy board, but it still shows you what you need to do. Once you tin the wire, you put it through the via hole and solder the wire onto the pad. Once you finish soldering that side, you can flip it over and do the same for the other side. Once you've soldered everything into place, you can use snips to trim off the excess wire. Make sure you do this for both sides. Finally, use a multimeter to probe around and make sure that everything's connected properly. Now you can trim off the edges of your board using the corner cutter in Lab 64 and sand down any jagged edges. And finally, the PCB is officially done.